1-2 is about properties of real numbers. Real numbers is the whole set of numbers that you talk about no matter what. Any number you can think of is what you classify as a real number. It's always broken down into subsets, though, between natural numbers, whole numbers, integers, rational numbers, and irrational numbers. The one people always mix up is rational and irrational. Well, what's the difference? Well, basically, rational numbers are any number that could be represented as a fraction. Irrational numbers are any number that can't, so that's why square root of 2, pi, we'll get to e later. The number e is not a rational number, so that's how you kind of know the difference. So if you look at problem 1, it says your school is sponsoring a charity race. Which set of numbers does not contain the number of people, p, who participate in the race? Well, if you think about just talking about people in general, you're never going to talk, you're really about half of a person, but all these include counting numbers. So even the rational numbers, when you talk about fractions, you can represent the number 1 as 1 over 1 or 2 as 2 over 1. So those are still rational numbers, but that can definitely be the number of people who participate in the race. So my answer here has got to be D. Why? Because you can't have the square root of 2 number of people, because it's not part of that set. Problem 2 is about graphing numbers on a number line. What's the graph for the numbers -5 halves, radical 2, and 2.6? So really, the only thing about graphing on a number line is that you kind of have to estimate where these things are located, because when a number line, you usually just put whole numbers. So 0, 1, 2, 3, -1, -2, -3. So you're kind of just assuming where this stuff is located on this graph. But if you're looking at the things here, what does -5 halves have? Well, if you need a calculator, plug it in, but -5 halves is just -2.5. So I'm going to go ahead and plot that on here, and it's going to be right about in the middle. So right there's that dot. Again, as close to accurate as you can, and go from there. If I'm looking at the square root of 2, what's the square root of 2? Again, punching a calculator, so 1.4. So where's 1.4 at? Well, not quite halfway between 1 and 2, but it's in there. So just put it right there in the middle. And then where's 2.6 repeating? Well, the repeating sign, which is that bar above, doesn't really matter. But 2.6 is a little bit higher than 2.5, so dot goes right there. Problem 3 is about ordering real numbers. So how do radical 17 and 3.8 compare? Use greater than or less than. Remember, the open mouth eats the bigger number, so I always remember it. So when you're looking at this, again, as simple as plugging in the calculator. The square root of 17 is about 4.123. So when I'm looking at how these compare to each other, how am I going to set this up? So it starts with square root of 17. So square root of 17 is 4.123 bigger than or less than 3.8. Well, it's obviously bigger. So remember, eats the bigger number, 3.8. Next, you take a look at the properties of a real number. And what this does is you're looking at how you can work with the real numbers. What properties are associated with, especially with addition and multiplication, because those are your main operations. Subtraction and division are usually just the opposites, so they kind of hold the same things to a point. But if you go through it, it's not a bad idea to understand what these words mean. The commutative property is a big one. Inverse property is definitely another big one, and we all know distributive, as we've always talked about that. So mark those down, get them in your book, we'll go on. Problem 4 is about identifying properties of real numbers. Which property does the equation illustrate? So if you're looking back at those properties, -2/3 times -3 halves. What are those of each other? Well, they look like reciprocals to me. So in this case, this is illustrating, and especially because the property is 1, it's the inverse property of multiplication. Take a look at one more real quick. We'll call this B. 3 times 4 times 5 equals 4 times 3 times 5. Now, the one thing I want to caution you of is you see the parentheses, so you're automatically going to think distributive property, but understand, what did they do differently? They just switched the 3 and the 4 here and here. Okay, so what is that called? That's called commutative property. And you could put a multiplication if you feel like it, but that's not necessary.